All right, welcome everyone. Let me give everybody a few moments to join, and then we're going to do a quick intro about Acelab. We're helping out with hosting today's event, and then we'll go ahead and get started with today's CEU portion presented by Autumn with ClarkDietrich. All right, looks like we've got a good amount of folks already hopping in. So Autumn, would you mind stopping your screen share for a moment? My colleague Helen, who works very closely with architects using Acelab's platform, is going to tell you guys a little bit about Acelab, how to get in touch with the folks who are presenting today, if you've got follow-up questions after today's event, and a little bit about what to expect in terms of follow-up from us. So Helen, go ahead whenever you're ready.
All right, sounds good. Hi, everyone. I'm Helen, and I was just admiring that image that Autumn had up with steel. I was like, oh, that's cool framing. Anyway, so what you can expect after this webinar is that you're going to have a conversation started for you within Acelab by my teammate Evelyn, and you're going to see that notification here of a new message. Whatever you put in, like I'm interested in talking to Autumn about lead times or pricing or anything like that, that'll be handled via this conversation. One other quick note, whenever a conversation happens with any manufacturer within Acelab, you also get an email as well. So you can just respond from your email, and a record of that will also be tracked within the Acelab portal. Other note too is if you have a specific project, we will set that up for you. But just kind of a fun fact for y'all, if you're newer to Acelab, every time that any conversation that you have in a project, also the whole entire project team can see that conversation, which can be really useful if someone's out sick and you need to, know some last minute information there. A couple other things here. If you need to get in touch with Autumn, this is the best way to do that. You can type in the brand name here, make sure you have brand selected. Then you can go to their page. Oh, there's the image that I was speaking of. And then you can hit contact here, and that team will take your request from there. This is also a great place to check in on all of their different options. And then you can also save these into your projects. So lots of great stuff here that you can check out. I encourage folks to save products to projects for a number of reasons, but I'm going to give you a little sneak peek of something that is coming. So right now we have our comparisons feature live. What this allows you to do is create really nice apples to apples comparisons between things. But this is something that we're releasing out only to early access users right now. This will be out for the general public in September. But like we were just looking at all of these great products here, what I can eventually do is basically generate my schedule from Acelab. So I can save all of these products, and then I can start to generate a schedule. All of these columns here are custom for you. This also pulls in from our database. So this will vary depending on what category you're looking at. You can create all kinds of different views. So you can share one with your contractor, one with your client, consultants, things like that. And then a couple other fun things. You can export this as a CSV. So you could create basically your, steel schedule here, and then you can create that CSV and export that into your drawing set, have it mirror what you need in your documentation. Another fun thing about this is that if you build out a library, you can then copy these products to your next project. So saving you some kind of startup time, you can go off to the races and keep a lot of information here. So if you're interested in learning a little bit more about this, I would love to meet with you. One of my favorite things is to understand how you work with your clients and your consultants and come up with a game plan of kind of how to set up your account, including how you can use these views. So looking forward to meeting with you. I will pass it back to the lovely Autumn.
Awesome. Thanks so much, Helen. If you're interested in learning some more, feel free to say yes to the poll we've got up, and Helen will also drop her meeting link in the chat so you can just book directly there. All right. Other than that, just a quick housekeeping item for me. Want to encourage folks to please submit any questions throughout today's presentation to the Q&A. We'll be keeping our eye on those. We should have some time to get to some of them live at the end of today's event. And if we don't get to your question live, we'll have a record of it. We did ask for AIA numbers upon registration. I'm also going to send over a form in the chat momentarily. In case you're worried you didn't submit it, you can submit it to us there as well as request a certificate if that's something that you need. All right, awesome. That's it for me. Autumn, thank you so much for joining today, for presenting today's course. Whenever you're ready, feel free to get started.
Thank you so much, Bo and Helen. And welcome everyone to today's CEU. We're going to be talking about some cold form steel framing connections. And as Helen showed on the Acelab website, for those of you that aren't very familiar with ClarkDietrich, we are the nation's largest cold form steel framing manufacturer. However, we do have a full lineup of interior and exterior framing solutions. So I definitely recommend taking a look at the website on Acelab to see all of the different products that you may or may not be familiar with already. So my name is Autumn Sullivan, and I've been with ClarkDietrich now for about 8 years. I'm the architectural representative for the Mid-Atlantic and Southeast regions, and I'm very happy to be presenting today. One little fun fact about me that I always like to start off with these presentations is that I'm expecting a little boy in about 10 weeks now. So if you see me huffing and puffing through the presentation or needing to take a break to take a drink of water, that is mostly why. I'm very excited to be welcoming a baby boy this October. Also, I'm not sure if Bo mentioned or not, but we will be taking questions at the end of the presentation. So if you have any questions relating to the slides, please enter those in the chat box and we'll talk about those at the end. All right, and with that being said, we'll go ahead and get started. So as I mentioned, today's presentation is going to be talking about full form steel framing connections and meeting today's architectural challenges. Now, this is an AIA continuing education program, and it's good for 1 learning unit for HSW credit. As Bo mentioned earlier, if you need the AIA credit, please submit your AIA number and we will make sure that you get your credit. And if you need a certificate, please also let me know and I can send those out to later on this week. So this is showing that ClarkDietrich is a registered provider of AIA. We also do have a few other courses that are very interesting. So if you are interested in learning anything more about our courses, you can also reach out to me. My email is autumn.sullivan@clarkdietrich.com. So we are going to be doing this course virtually today. And like I said, it's good for 1 health, safety, and wellness learning unit. Lastly, this presentation is protected by U.S. copyright laws, so reproduction, distribution, and display of this presentation without our permission is prohibited. So let's briefly look at our agenda today. We're going to be covering 5 different topics. The first one is going to be deflection and drift connections, and then we're going to be talking about rigid connections. We're going to move on to some specialty clips and connectors, and then we'll talk about some labor-saving solutions when it comes to different connectors. Lastly, we'll look at some of the industry tools that are going to help you aid in design. And just kind of elaborating on each of those points a little bit more. When we talk about deflection, we're going to gain an understanding of its significance in accommodating that movement that's needed, and also identify the various different types of deflection and drift clips, whether it be for curtain wall framing or bypass connections or head of wall systems. Then we'll be looking at the support clips that are going to be suitable for rigid attachments in building construction. Third, we will be taking a look at some of the specialty clips and connectors that are going to help enhance the performance and durability of building structures. These could be things that help with sound, fire ratings, and things like that. Then we're going to be looking at some labor-saving products that are available in the industry. Those are going to help improve speed and efficiency, 2 things that are very important right now. And lastly, we're going to look at some of the industry tools that are designed to aid on the design of the connectors. So first, let's talk about deflection. Building deflection is going to refer to the bending, flexing, or movement that's occurring in a building's structural elements that's going to be in response to various loads and forces. So a crucial aspect of cold form steel framing design is its ability to accommodate vertical movement of the structural elements. So those could be the floor and roof systems, by allowing them to deflect either downward or upward without placing an excessive axial load on the wall stud members. It also will help with the gypsum wall boards or other substrates. And the cold form steel framing connections are also crucial for managing deflection, particularly in coastal and high seismic zones that have a higher risk of movement and stress. Now, when we're looking at compression and extension, this is going to be called out by Section 1604 General Design Requirements of Chapter 16 of the International Building Code. So it says that the structural systems and members shall be designed to have adequate stiffness to limit deflection, including roof and floor members. Now, roof members typically move in two different directions. It's going to be downward, which is known as compression, or upward, which is known as extension. Here we have some examples of the different loads. So for the roof live load, that's going to be something that's happening during maintenance by workers, equipment and or materials, and specifically movable objects. Next, we have a snow load, and that's going to be the weight of the collected snow on the roof, including snow drift. Then we have a wind load, which is the pressure applied by the wind, and a dead load, which is the weight of the materials in construction that's incorporated into the building. So for the floor members, those typically only move in one direction, which would be downward. So that's going to be a result from the live loads that are introduced by the end and occupancy of the building, as well as the dead loads. So if the structure has multiple floors, the downward movement of one of the levels can actually cause an extension at the head of wall above. So that's why it's also important to calculate those into your design. And when we talk about head of wall deflection joint and gaps, the deflection joint is going to be the gap that's between the top of the stud framing and at the bottom of the floor or roof above it. Now, this distance is going to be determined by the architect or structural engineer, so it does need to be designed. And the distance between the top of the gypsum wallboard and the underside of the floor or roof shall also match that measurement. So whether it's a 1-inch deflection gap, 3/4 inch, that should always be notated on the design. So when specifying deflection connectors, it's important to consider deflection and standoff distances. Here we have those definitions on the slide. So deflection distance is going to refer to the measure of the maximum vertical distance that the primary structure is anticipated to move due to those loading conditions. Now, standoff distance is the space between the secondary and primary frames. Now, that space is going to allow the contractors to install the cold form steel framing in a true line while the structure of the building may be slightly out of plumb from floor to floor. So let's jump into the first section, which is our deflection and drift connections. Here we have a rendering that's going to show some of these connectors and where they're actually installed and attached. I think this is a great tool to help you visualize where some of these products could go, and also help you determine which one would be used for the design. So then for deflection and drift connections, these are going to be structural components that are used in the building construction to help mitigate deflection and drift effects. Now, they're designed to connect different structural elements, and those could be beams, columns, or braces. That's going to enhance their overall stability. One of the main importance of connectors is the proper installation. That is very crucial to the effectiveness. So it's very important that the contractors are following the installation instructions. Lastly, most of the deflection clips are going to include proprietary deflection screws. Now, these have been specifically designed to provide the friction-free deflection, and these fasteners are going to eliminate drag, binding, and resistance that can often occur with common fasteners. So it's important to take a look at the fasteners that are included with the connector based on the manufacturer, and make sure that if it is not including a fastener, you find something that's going to, again, help you eliminate the drag, binding, and resistance. So the first clip we'll take a look at is the surface mounted deflection clip. This is going to be used for medium standoff conditions, and it's used to attach vertical studs to the edge of the structure. So we can see on the detail here how the clip is actually being connected to the structural angle to connect to the building structure, and then it's attached to the stud framing. So it's going to help provide vertical building movement up to 3 inches. And that's all going to be dependent on the slots that you see in the clip on the slide. Also, as I mentioned before with the screws, the proprietary screws are usually used to attach the clip to the stud, and you can see an example of the screw here. It does have that built-in shoulder to allow for that screw to move up and down in the slots. Some other manufacturers would offer a washer to go to kind of fill that position if they're just using regular screws. Now, as far as connecting it to the actual building structure, it can be made with screws, powder actuated fasteners, or drilling concrete anchors. Again, it's very important that it's installed the way that it was tested and designed. So most clips and connectors will have an embossed mark on the scored line of the clip to show you where exactly the screws need to go, or the anchors. It's also important to be looking at the number of screws used on the clip to attach it, because that will also affect the load data. Here we have a video that's going to show that surface mounted deflection clip. I apologize, there is no sound, but here we see there's a typical roof deck with the angle at the top, or the pour stop. And the shorter flange is going to be attached to that angle, and the longer leg will be attached to the stud framing. So the proprietary screws are installed into the center of the clip. And like I mentioned before, this is going to provide up to 3 inches of deflection, or 1.5 inches up and down. So moving on to the next type of connector, this is going to be the extended reach style curtain wall connector. So this is used to connect bypass style curtain wall assemblies, similar to what we just saw, but it's going to be attached a little bit differently and underneath of that red iron. So it's commonly used when large standoff conditions exist, or when that stud framing is going to bypass that structure a little bit more. Again, that could be used to make sure that the stud framing is in a perfect line, in case the building might not be completely perfect or plumb. So this is going to allow for vertical movement up to 2.5 inches. And again, it's going to be embossed with the fastening pattern to ensure the accurate placement of the fasteners. These connectors are typically available in standard lengths of 12 inches to 15 inches. And sometimes they could even be customized to lengths up to 24 inches long. So again, it's going to allow that framing attachment well beyond the perimeter of the structural steel. As far as installing it, the connector has to be engaged to the building structure a minimum of 4 inches to allow for that load. If it's connecting to the building using mechanical fasteners, the fasteners must be equally spaced along the flange of the extended reach connector. And this one also would be used with a shoulder screw, or a screw with a washer in the slotted holes to allow for the deflection. Next, we have the offset bypass vertical slide clip. This is used to attach the exterior curtain wall studs to the building structure, and it's going to provide around 2.25 inches of vertical building movement that's going to be independent of that steel framing. This clip is also going to provide variable standoff and eliminate the need for shims. It is also a versatile option and is available in both right and left versions. The profile has a vertical leg with vertical slots to allow for the compression and extension movement that we talked about in the beginning of the presentation. And this clip can also introduce rotation to the structural element, so the structural engineer of record should review and approve this type of connection as well. Now this clip is going to easily fasten to the floor or ceiling beam and is secured to the stud with the deflection screws. Again, it's going to help restrict lateral movement, but enable that vertical movement. And talking about a different type of deflection connection we haven't seen yet. This is an in-plane style or head of wall deflection clip. This is designed for use where there's minimal or no standoff conditions, and it's going to provide a positive attachment. So it is screwed into the top track as well as the stud. So the studs must be less than full height in order to enable up to 2.5 inches of vertical movement. And again, you would use a proprietary screw or a screw with a washer in those slots to allow for the vertical deflection. Now this one is very similar to the one that we just looked at, but this one is the head of wall drift clip. So it's going to provide both vertical movement and lateral movement, which is known as drift. So this clip is going to be used in place of or in combination with a deflection track, similar to what we just saw on the previous slide. And the studs must be less than full height in order to enable up to 2 inches of vertical movement. Similar to the other connectors, the attachment to the structure can be made with screws or concrete anchors to allow for that lateral movement. So it also comes in 2 different designs. It comes in a light gauge to be designed or installed with structural stud gauges, 20 gauge, 18 gauge, or 16 gauge. And then there is also a heavy gauge that is designed to be installed with structural gauges of 14 gauge and 12 gauge. And lastly, one more drift clip that we can look at is the surface mounted drift clip. So this clip is very similar to that very first clip that we saw, the bypass deflection clip. But again, it's also going to allow for the drift movement as well as the deflection movement. So it's going to attach the exterior curtain wall studs to the building structure. The screws are provided with each clip to allow the attachment to the wall stud, as well as these ones also come with connections that allow you to connect it to the building structure. And you can see on the slide here how it has those step bushings to allow for that lateral movement. So here we have another video just showing how it's used and installed. Again, we have a structural angle. And there also are multiple lengths and gauges depending on the load or the stud width needed. And here we have the deflection screws. That's going to be installed in the center of the slot to allow for that stud to move up and down. So here we have our drift movement, which this connector is going to allow for 2 inches of lateral movement as well as 2 inches of vertical deflection. Next, we have a couple of different types of connectors. The first is going to be a drift rail and clip system. Now, this is a 2-piece system that attaches the curtain wall studs to the structure. And again, it's going to allow both drift and deflection or the vertical movement. It's going to allow for 3 inches of vertical deflection. And the clip, the way it's installed, it's a little bit different. The clip is actually going to rotate into the rail, making it a little bit easier for installation. Now, if you did not want to use this as a drift system, there also are locking angles that can be used to prevent it from sliding left and right. But as far as the studs go for deflection, they would use the proprietary shoulder screws that come with the connector, or they can use regular number 8 screws in the smaller holes to the right and left of the slots. And that way it would resist all movement. So you can use this connector as either a drift and deflection system, a deflection system, or a completely rigid system. And this one's going to be a bit similar to the drift rail clip system that we just saw. However, this one is the drift headed rail and clip system. So it's going to utilize that C-shaped drift headed rail and the Nelson studs. So the rail itself is welded to, is installed in that actual concrete. And then the clips are, again, twisted into place and installed to the studs. Now this one's more ideal for panelized construction and multi-story applications. Oh, we just got a question asking if the audio has gone silent. I apologize. This one does have sound, so if you're not hearing that sound, that's on me. I apologize about that. So here we have the locking angle or stopping clip that's going to restrict that lateral movement. And here we say the screws being installed into the holes instead of the slot. So again, this is very popular with panelized construction because the clips can actually be installed from the inside of the building, and the stud framing can be tilted up to be installed to the building structure. And again, I apologize that there was no audio on that. If you have any questions, feel free to reach out to me and I can share it with you. So moving on next to our rigid connections. Here we have some examples. Our rigid connections are going to be anything including framing clips, support clips, bridging clips, header clips, or anchor clips. So we're going to talk about a couple of those. Now, the main purpose of the rigid connections are to transfer the loads and resist shear, tension, and or compression. Like I said before, they're used for multiple construction applications. So it could be used as a framing, support, bridging, or anchor clip. One of the benefits to the rigid connections made by manufacturer is that they're going to be pre-cut and shipped to site that already have the lengths and load tables associated with them. So instead of someone on the job site just chop cutting unpunched ankle, they're going to get actual tested connectors. They're also usually pre-punched to allow for quicker screw attachments. And again, the holes that are associated with the clips and fasteners are also tested members. So those are helpful in the design phase. As far as the fastening options, it's crucial to specify the proper fastener, whether it's a number 8 screw, a Hilti quick bolt, or anything like that, in order to ensure the proper performance of the connection. Now, the most common and widely used connection methods are screw connections, powder actuated fastener connections, and welded connections. Now, they're all going to provide a different load. So looking a little bit more in detail at the framing clips, those are going to be used to attach and support numerous rigid framing conditions. They're going to be ideal for most rigid connections, including shear, tension, and 2-axis loading. As you can see on the slide here, this connector has stiffened corners that results in superior design values. And the clips are also attached to the cold form steel framing members using self-drilling screws that are driven through the clip holes into the steel framing. So we can kind of see that on the detail here where it says attached to slab edge as required by design. Again, it's very important for the contractor to follow the required fastening placement and the anchor placement pattern to achieve that allowable load that it was designed and tested with. As for the support clips, those are used for rigid standoff conditions, most commonly window and door framing, corner reinforcement, or floor framing applications. The detail you see on the slide here is for a floor framing application where the joist is connected to that track. Now they're designed to provide superior design values for shear, tension, and the 2-axis loading conditions. And the clips are typically attached to the cold form steel framing members using those self-drilling screws. Again, they have to be connected with the clip holes that the manufacturers produce. And it's important to follow the required fastener placement and anchor placement to achieve that allowable load. So here on the slide, like I said, that top one, we have a floor framing application, and the bottom photo is going to show a rigid condition where the support clip is used to secure the stud to the bottom track. Again, looking at these types of connectors, you know, I would say 10, 15, 20 years ago, most of these connectors were just, you know, unpunched angle or track that was on site that they would cut. And now there is a whole market just for support clips that have that tested and designed values to make it easier and the structure more sound. So next we'll talk about bridge clips, specifically cold roll channel clips. Now, cold roll channel is one of the most common bridging methods that's used. It's going to provide resistance to the stud rotation. And we can see here how it's actually installed. So the cold roll channel is typically installed through the knockout of the stud. And there are a couple of different bridging clip options, whether it be one like this, where it twists through the knockout of the stud and is attached to the cold roll channel, or you can use something that we just saw on the previous slide, which is just a regular L angle clip to secure one leg of the clip to the web of the stud, and then the other leg of the clip would be installed directly to the cold roll channel. So the clip angles must be used with screws to brace the cold roll steel framing properly. The bridge clips are designed to facilitate the rapid, efficient installation of 1.5-inch cold roll channel. You see here, this clip is just used for that 1.5-inch cold roll channel. However, if there is a 3/4-inch cold roll channel that's being used in the stud knockout, there are also connectors for that. As far as this bridge clip on the slide, it's going to allow for as little as 1 screw for the connection to the cold roll channel. So it makes it a little easier and faster for the installation process. And it does allow for a more rapid installation compared to a standard clip angle. Because if you were using a clip angle, you would have to attach the one leg of the stud to the web one leg of the clip to the web of the stud, which would require at least 2 screws, and then 2 screws to the actual cold roll channel. So you're using 4 screws compared to 1 screw. So here's a video, and again, I don't think this one has audio. So here we have our typical stud framing. And the proprietary bridge clip that you see here is installed by rotating it into place. And you see it has 2 different slots on the side of the clip that's going to friction fit into that knockout. So the channel is then passed through the knockouts of the stud. And then you would install it with the 1 screw or possibly 2, depending on the load condition. Now looking next at anchor clips, these are typically used as moment connections for knee walls, shear walls, and truss connections. They're going to be designed to resist horizontal, torsional, and vertical uplift loads. And as you can see on the slide here, this clip that is at the top right-hand corner has those reinforced stiffening ribs and plates that are going to provide superior design values. So it's all going to depend on what you're actually needing in the load conditions, and that's going to help determine what connector can be used. There are a couple of different anchor clips that are offered that are going to have different leg sizes and gauges. And then as you see at the bottom there, that connector also has an extra plate to reinforce the stud connection. Lastly, for the rigid connections, we're going to talk about a pony wall. That's going to be intended to support those out-of-plane loading of the cantilever partial wall systems. Typically, they're unsupported at the top track, so they need that additional support. They're primarily used when the studs don't anchor to a top track at the head of wall to support the knee walls. So a good example to be thinking of at this is going to be a counter of a nursing station, or any kind of partial wall that you see in an office building. So basically the out-of-plane loads are transferred to the floor system through a thick base plate, which you can see on the slide here. And that base plate is actually already welded to the pony wall stud. Now this is installed inside of the track or directly to the floor structure with a combination of anchors, or it can be welded. And it's designed to eliminate the on-site fabrication and load size guesswork because it is a tested product. So previously, many contractors were used to using, kind of custom-made pony walls that did not have any test data or load tables available. So we've heard stories about how a contractor would go up to a partial wall and they would wiggle it, and if it wiggled, they would need another one. And if it didn't wiggle, they would be good. So again, it takes the guesswork out of the design, and everything is able to be designed ahead of time to avoid that guesswork. So moving on to some of the specialty clips and connectors that are on the market. One of the newest ones on the market is a gusset plate that's going to be designed to help the MEPs, the MEP components pass through after it's been repaired. So essentially, if a stud knockout is changed or cut in any way, it loses its strength and stiffness, and it's typically not allowed by IBC. However, there is a quick fix now that can be used, and it's a 2-piece gusset plate that's used. You would install this over top of the knockout and use the provided screws to install it. Again, it's going to restore that structural integrity of the steel framing. or any field modified opening. Next, we have a universal clip. So this was kind of seen when we talked about the drift connectors. As you can see on the actual clip picture here, you can see that the clip has slots for deflection, as well as small holes on the top and bottom of the slots that can be used for a rigid connection. So this is a versatile connector that's used to attach the exterior curtain wall stud to the building structure, and it will provide either a rigid connection or a deflection connection. This clip is used for medium to larger standoff conditions, and it's a fast one-piece universal installation. There's no left or right-handed clip needed. So if you are specifying a connector, this one would be pretty useful because they can again use it for deflection or a rigid connector. If it's being used for a deflection connector, it can provide vertical movement up to 3 inches. And this clip is a heavier gauge than most typical clips. Most typical clips are 16 and 14 gauge. This one is a 10 and 12 gauge clip, so it does have higher capacities when it's used in applications where the higher capacity is required. Next, we have sound isolation clips. Many of you may be familiar with these already. There are a couple of them on the market, and this is used to provide effective acoustic separation. Now, it's used to be designed to be used alongside of a 7/8 deep drywall furring channel. So it's going to be a combination system, whereas you can also use a resilient sound channel. So again, its primary purpose is to secure the gypsum wall board, and it can be used on walls and ceiling applications. But again, it's going to help provide that acoustic separation. It is ideal for use in most multifamily dwellings or hotels, theaters, hospitals, anything that's going to require higher STC ratings. It does comply with UL test standards, and this clip in general is going to provide test results for type X and type C wallboard. And this one also has a maximum design load of 36 pounds for that gypsum board. Next, we have a fire blocking connector. Now, fire blocking is specifically designed for use in conjunction with approved fire blocking materials based on Section 718 of the IBC. That's going to provide the requirements for both fire blocking and draft stopping in the combustible concealed spaces. Now, this system simply installs by twisting it into the stud flanges and screwing it into the web studs. As you can see on the slide here, there is a kind of a flag on the connector that's going to go into the soft side of the stud or the open side of the stud. And then there is a flag that goes down to be installed or connected to the hard side of the stud. So it is a one-piece assembly that does eliminate cutting, notching, and attaching clips. It's available for both 16 and 24-inch stud spacing, as well as a variety of gauges. And this can be used for use on structural studs only that have the 1 5/8 flange. Next, we'll talk about some of the labor-saving solutions that are out there. We briefly talked about the bridging systems that are currently available with the cold roll channel and clip method. This one is a bridging bar that's also going to facilitate the rapid erection of non-structural and structural studs. But it also helps lay out the grid work because it does have notches at 12, 16, and 24 inches on center. So not only is it going to help the twisting of the studs, it also will help the contractor lay out the spacing and make sure that they are all properly aligned. So the slots have been pre-engineered to hold studs in place by utilizing the shear to bridge studs in a rigid grid work. And again, this is going to be used in lieu of the cold roll channel and clips. So when you compare the traditional installation to the installation of this cold roll channel or this proprietary bridging bar, as we saw in the video, the U channel would typically be installed through the knockout of the stud, and then you would use either a clip angle or another type of bridging clip to secure it. Whereas the bridging bar, this has to be twisted through the stud punch outs and then rotated into place to grip the edge of the stud. So it does help with speed when you're installing them. Next is the wood backing system. So this is going to make wood backing installation easy and economical by eliminating cutting, notching, ripping, and routing of the plywood when you're using it for backing with steel studs. There was a time study done that showed that it reduced the steel stud backing installation time by up to 75% based on the design. So the wood backing is also fire retardant and it's pressure treated. That's chemically treated to reduce the flame spread and smoke development. One other important thing about this type of wood backing system is that it can help contribute lead points to your next project. And it also provides extra screw pull-out strength for heavy backing applications. So we see this mostly used in hospital systems where they are hanging monitors off the walls or something along those lines, cabinets. But it is available for 16 or 24 inches on center framing. And again, compared this method to the traditional method, if you were cutting each piece of wood, you would cut either a 2x4 or plywood to either the 16 or 24 inch on center spacing that you need. But then you would also have to notch on each side of the block to allow for it to go inside of the flange of the stud. You would then slide the block between the two studs so that the notched end of the block is in the C-shaped channel of the stud, and then install it with your screws. So this piece that you see here on the slide, again, it has multiple pieces of wood. So there is a starter edge that you would use first to screw into the flange of the stud, and then it's going to wrap around each flange following that. So basically, once you screw in the starter edge, all you have to do is flex it around each following flange until your run is complete. So there is a video that also shows how this one is installed. So you can see that for the starter edge, there is a base plate and there is a dado cut around each edge of the plywood backing so that it can just wrap right around that flange of the stud. Now these pieces are typically 4 foot in length. So if you needed to add more to it, you would just continue on where the previous one stopped. And again, that's good for using cabinets or for installing cabinets, shelving, monitors, things like that. And the next solution that we'll talk about is the box headers. Now you can see at the bottom here that the types of headers that it replaces, but essentially these box headers are one-piece headers and jams that eliminate the need for additional studs, tracks, and screws required to frame conventional rough openings. They're going to be pre-cut and are specified lengths to eliminate field cuttings. Basically, this is going to help reduce material pieces and screws up to 50% because it is all sent to the job site with the designed length. Now, the top of the header is open and the header and jam assembly are flush, so it makes it easier to install the insulation while eliminating the need to pre-insulate the headers prior to installation. And like I said before, the types of headers that it replaces are typically going to require 1 or 2 studs, as well as 2 different tracks, and then connectors as well. So you're going to have someone on site chopping all of these different components in order to make one of these header solutions, whereas this one can just be sent to the site with 3 different components, which would be the jam, the header, and the connector that's attached to the actual jam. Lastly, we'll talk about some of the industry tools that can help you when you're evaluating connectors in the design. The first one are all of the specification websites that will help you. The main ones that we know of are Deltec Spec Point, Rib Spec Link, ArtCat, 4specs.com, and also manufacturers will also typically have their specifications on their websites. As far as the related sections of the specifications, any type of structural connector is going to be under 5400, which is cold form metal framing. And then you'll also find connectors under 92216, which is the non-structural metal framing. But again, most of the connectors that we see are under that cold form metal framing section. Now, it's very common for cold form steel framing installers to fabricate clips and connectors in the field. Like I said, it's been more recent, whereas connectors are actually designed rather than just fabricated. And I think that's because they've seen many benefits to specifying the pre-engineered connectors, and because they are tested to perform exactly as required for each application. So here are a couple of points to keep in mind when thinking about specifying the connectors. The first is that the high performance buildings are always going to require an assurance of expected performance in every structural element. Next, these connectors are always designed and tested for allowable load capacities. And those load capacities are very easy to find on the manufacturer's website or in the catalogs. You can use those capabilities to base the calculations on. And there also are third-party data and certifications supporting the performance and adherence to certain standards. Specifying pre-engineered clips and connectors are going to save time and labor in the construction process, as we saw in the last section. And the field fabrication of custom connectors can be very time-consuming, especially in large commercial projects. So using a product like that wood backing system that's going to help save 75% of labor is definitely valued. And lastly, most of the connectors are going to have those pre-punched holes that allow proper alignment of the fasteners and also ensure that the contractor is installing them the correct way in accordance with the design. Now, as far as evaluation reports go, connectors aren't considered structural elements that are going to play a crucial role in the design of the buildings, but they want to make sure that they're safe even when subjected to high winds and seismic forces. There are adherences to building codes and regulations for safety and structural integrity. So there are a couple of third-party testing companies that verify that the connectors do meet the specified requirements and performances set by certain codes and standards. So we could see a couple of them on the slide here. The first one would be Intertech, next would be ICC, there's IATMO, and then also the SFIA, which is one of the largest steel framing associations, has their own certification for connectors, and they the SFIA has around 1,300 members of it that can help all facets of the building design. And lastly, some of the manufacturers have interactive clip models. We saw a couple of these throughout the presentation that we can see here. So this is going to show what the connector is and where it's actually at on the building. And for most of them, you can click on them and be taken directly to a submittal page, load values, videos, things like that. So it's very helpful if you're not too familiar with different types of connections. You can look to see what types of deflection clips there are, rigid, what clips there are available for floor framing systems, as well as bridging, bracing, backing, and roof and truss connections. So that's all I have for you guys today. I do see that there's a couple of questions in the chat, so we'll try to answer those while we still have a couple more minutes. And if you guys do have any more questions, feel free to add them to the chat or send me an email after the presentation. So the first one is, how do they typically secure the drift rail during construction when it's embedded into the concrete slab? That might have been asked before we saw the video, but basically the drift rail is going to be set into place while the formwork is being installed, and then they would pour the concrete slab. And those Nelson studs will help secure it into the actual concrete. Next we have is, what is the ASTM used for these connections? So that's going to depend on the building code, right? So for IBC 2015 and before, we'd be looking at ASTM, was it C955, I believe, or IBC 2018 and 2021, we'd be looking at AISIS 240. Someone asked, what's the typical spacing used for the pony wall stud supports, as the picture does not show supporting channel at each pony wall stud? That's going to be typically based on the actual design. However, we have seen it mostly spaced at 48 inches on center. The next question is, is there a product similar to the pony wall framing connection for walls that are 9 foot tall but do not reach the structural deck below? So not to my knowledge, there's no pony wall that will reach that height. However, if you reach out to me after this, I can get you in contact with our engineering team to see if there's another solution that I'm not aware of. But as far as I'm aware, none of the pony walls will help you reach a wall that's 9 foot tall. The next question is about the sound clips. Have the sound transmission reduction clips shown also been tested with typical drywall, not just type X and type C? There are numerous test reports that are available on our website that show how the STC is going to be affected by the different types of conditions. So I would have to look at that chart to be able to answer your question definitively. But again, that is on our website, so I can reach out to you after this presentation to walk you through that. And the next question we have is about the fire blocking. Do the fire blocking pieces still need to be fire taped or sealed in some way that provide the listed UL assembly? Can these be used in a rated floor wall assembly? Again, as far as I'm concerned, there's no additional need for any kind of intumescent tape or anything to go on the actual fire blocking pieces. And the last question also is about the fire blocking. Are fire blocking between stud infill panels meant to support fire safing type material, wool, floor perimeter insulation, and curtain wall systems? No, I was reading over that code earlier today, and I can get more information from our technical sales rep, but I don't think that it's actually meant to support any type of material. Again, it's just to prevent that the fire from going past the wall system up into the attic, or any kind of draft.
Great, awesome. Thank you for
I
our questions, Autumn. That was great.
yeah, no problem. I look at the clock and I see it's 2 o'clock exactly. So
Absolutely
think
perfect timing.
you're good. Yes.
Awesome. Well, just want to say a quick thank you to everyone who attended today. We appreciate you coming out and asking so many great questions. As you're leaving, be sure to grab any of the links from the chat. Got Helen's meeting link in there, the link to the page on Acelab where you can explore some more about ClarkDietrich's products and get in touch with their team. And there will be a quick post-event survey if you've got a moment or so to fill that out as you leave today's webinar. That's super helpful for us. You can also add any questions that you might have regarding the presentation there as well. Autumn, thank you so much for a wonderful presentation, and we appreciate you coming out and presenting with us today.
Thank you. Have a great day, everyone. Thank you for attending.
All right, thanks everyone. Have a good one.